Hello everyone, my name is Mohammad Usman and I am attending HAP725 Statistical Process Improvement taught by Professor Alemi at George Mason University. For the purposes of this presentation, I will review how to solve assignment number 1 from our lecture on using and creating causal control charts. I would recommend reviewing the assigned reading on causal control charts provided by Dr. Alemi prior to beginning this assignment. A common problem we may see across healthcare organizations is excessive boarding times while patients wait to be seen in emergency rooms. In order to address this issue, the organization may look at many factors, including backup for imaging, bed availability, or the number of personnel available to assist patients. Our dataset above shows patient counts for the various strata, including the total examined and those with excessive boarding. For our scenario, we want to analyze if the addition of emergency room personnel leads to a decline in excessive boarding times, given all other reasons remain constant. Months 1 through 13 are our controls and represent pre-intervention where no additional personnel have been added. Months 14 through 25 are our cases and represent post-intervention where additional emergency room personnel have been added. So let's identify a method to solve this problem and perform the steps for solving the problem. To solve this problem, we want to use the counterfactual model for causal probability. The basic reasoning behind this method is to create a control group which resembles all the cases as the intervention, but without the intervention case. We can then compare the control and the cases to see if there is a causal effect. In other words, for our assignment, we calculate the probability of excessive boarding time, specifically focused only on the addition of personnel, by using weights to normalize the total number of cases and controls, therefore balancing pre- and post-intervention time periods. So this will lead us to two sets of control limits: weighted upper and lower controls and unweighted or unadjusted upper and lower controls. So step 1, we want to calculate the average of our pre-intervention controls. This simple calculation can be done by using the average function in MS Excel. You can see the average controls calculated here in column AB. In step 2, we want to calculate the weights for our post-intervention cases in order to normalize the pre-post intervention data. As Dr. Alemi mentions, weighing the controls helps ensure that the rate of occurrences for alternative causes in the pre- and post-intervention groups are the same at any post-intervention period. This weighting needs to be completed for all groups as seen above. For step 3, we weigh the controls. This can easily be accomplished by using the Microsoft Excel sum product function as seen here in column P where the blue arrow is pointing. Next, we want to weigh the excessive boarding times. This is also completed using the Microsoft Excel sum product function. And you can see the formula in the formula bar there and the arrow pointing to the value in column P. The formula is also listed there at the bottom of the slide. Finally, we want to develop the weighted control limits. In order to do this, we need to calculate the probability of excessive boarding within our weighted controls and then use that to derive the standard deviation as well as the adjusted or weighted upper and lower controls. You can also calculate the total weighted average probability of excessive boarding as seen by the green arrow. Once you complete this calculation for one of the columns or one of the time periods, such as 14, you can just drag the arrow across the remaining columns to carry over the functions. The calculations are also listed at the bottom of the slide. Another important aspect of this is calculating the unadjusted or the unweighted control limits. So this kind of helps us bring into perspective how things look when unbalanced. After plotting our data into a control chart, we get the above view. The plotted observed rate is the unadjusted probability of excessive boarding. In this control chart, the weighted or balanced control limits are shown in the solid red line, and the unweighted limits are shown in the dashed red line. Based on the given sample data, the observed measurements are radical and fall mostly outside of both the weighted and unweighted control limits. This means that although we have added additional emergency room personnel and given it weighted controls, we cannot support the statement that emergency room excessive boarding times have declined. Hopefully this has been helpful to everyone in solving assignment 1. Please don't hesitate to reach out if you have any questions. Thank you. Bye-bye.